Hypothalamus Artificial Intelligence, HI, and General Algebraic Modeling System, GAMS, present their service offering. Mathematical Models as a Service on the Cloud. This facilitates access to enterprise-wide optimization systems and artificial brains developed by HI, a service for companies undergoing digital transformation. To provide these services, HI is supported by its business partner, GAMS. HI is a knowledge factory dedicated to developing its computer platform based on artificial intelligence, using a unique vision at a global level. HI stores all its models using OPTEX, Optimization Expert System, for the development of multi-problem mathematical models, and using the principles of generative artificial intelligence to produce the algorithms and all the software used by HI's solutions, without programmers. HI has established an alliance with GAMS, General Algebraic Modeling System Incorporated, to jointly produce optimization solutions using mathematical programming. The General Algebraic Modeling System, GAMS, is a high-level modeling system for mathematical optimization. It is designed for modeling and solving mathematical programming optimization problems. GAMS is tailored for complex, large-scale modeling applications, and allows you to build large maintainable models that can be adapted quickly to new situations. Models are fully portable from one computer platform to another. The HI-GAMS Alliance is able to solve complex problems by facilitating the diffusion of mathematical programming. HI-GAMS solutions are integrated into specialized enterprise-wide optimization systems, covering multiple industrial and socio-economic sectors. MOS, Mathematical Modeling as a Service Framework. All the mathematical models of the decision support systems produced by HI are offered under two modalities: on-premise, on the client servers, and on demand, such as mathematical models as a service, in a private or public cloud. The two modes can be mixed according to the convenience of the end user. Value Chain Optimization. MOS is an advanced decision support system, DSS, made up of multiple mathematical models, predictive and prescriptive analytics. These models are the same as those used by large companies, the big difference is their cost of access. MOS socializes current analytical technologies, mainly those related to artificial intelligence, machine learning and mathematical programming. In this way, companies increase their value by fully entering the new world, generated by the digital transformation of Industry 4.0. Why MOS? Because a single instance of the mathematical model is useful for several users. Installing the software locally is a thing of the past, plus MOS provides a way to aggregate, collect, and centralize valuable application data. In MOS, the cost of developing a complex mathematical model is paid by several users. The alternative that is replaced is that a single user pays only for the mathematical model. What is MOS for? In addition, in the past there was a constant problem for large and medium-sized companies related to the amount of mathematical modeling software they had to acquire to support different types of decisions within their organizations. All this meant buying optimization software, basic algorithms for solving numerical problems and mathematical models that represent real-life problems, i.e., paying for specialized software licenses, high-performance computers to solve math problems, and servers suitable for interconnecting different users within a company. Mathematical Models Software Factory. When the client requires specialized models, HI-GAMS offers the services to design and implement models in a short time, and at manageable costs for all types of companies. Mathematical Models Software Factory is a service offered by HI in which the client provides HI-GAMS with the formulation of the mathematical model and a test database, and HI-GAMS provides the client with a decision support system composed of source code of the mathematical model and the selected optimization technology, information system data model, and, if it exists, a test case to test the correct functioning of the model.
En más, los modelos matemáticos se proporcionan como un servicio a través de Internet de manera centralizada. Los usuarios tienen que crear cuentas individuales y todos los costes generados se facturan diaria, semanal, mensual o anualmente, dependiendo de las opciones y la decisión de quien contrata el servicio. Los algoritmos asociados con los modelos matemáticos se ejecutan en línea en una computadora de alto rendimiento en la nube. El proceso de mantenimiento y actualización están en manos de HAI y no de los clientes, lo que supone un gran alivio para los usuarios, que solo se limitan a acceder al software a través de un navegador y pantallas de acceso especializadas. El sistema de información con los datos de entrada y salida puede residir en el servidor HAI o en un servidor del cliente, cualquier servidor de tipo SQL que pueda conectarse a los modelos matemáticos. El manual del usuario, ejemplos, plantillas de MS Excel y otros documentos de apoyo están disponibles a través de Internet o por medio de archivos PDF.
How does MOS work? Customers can use application programming interfaces, APIs, to connect them to other functions according to their needs and requirements in a practical and simple way. At the customer's request, GAMS can introduce variations in the mathematical models to meet the customer's specific requirements. The new specific model will be identified by the server to be used by the interested user. The user only needs a device with an internet connection to log in and start receiving the contracted product. These conditions may vary depending on the bilateral contracts with the user. MOS. Mathematical Modeling as a Service. IT solution. The current state involves the integration of edge computing and cloud computing to implement an enterprise-wide optimization system composed of multiple highly complex mathematical models. The integrated model, an artificial brain produced by HI, can be distributed across various types of computers. Artificial brains are backed by the technological power of computing. It is traditional to associate mathematical modeling with large-scale computing, which today is linked to cloud computing, made up of bit supercomputers, and the birth of quantum computers, and their commercialization process, which will be by runs of applications, which will be solved in the blink of an eye. As a standard configuration, HI proposes to use a CPU-S cluster with many GPUs. This implies that applications are deployed using intelligent devices based on the symmetrical atomization of systems and/or processes. As is the case with GPT-based artificial intelligence. Soon, HI hopes to offer the OPTEX GPU solver, as a CPU-S network specialized in solving optimization problems. This possibility is not available at this time. The computational support of a large company will integrate multiple types of specialized servers, all of them supplied by third parties, which must guarantee their correct operation. This central computing system will be accessed by users of companies that use MOS, working in an external logical network. The company's data and application servers will be located at this same layer. As we have seen, there are multiple architectures that a company can implement to meet its needs. The economic implications vary with the user's decisions and needs. At this level of the proposal, the following configuration has been assumed. In the cloud, Optimization Server provides compute time hosting, optimization platform licenses, and mathematical model licenses. Optimization Database, temporary files used by HI mathematical models. On the client, Company Database, permanent files used by the company, and potentially read by HI's mathematical models. Business User, Cloud Optimization System Access Workstations. GAMS provide the optimization services in the cloud. One of the great advantages of MOS is that the user can be an SME, small and medium-sized company that would otherwise not be able to access advanced artificial intelligence. GAMS offers 4 tools for users: GAMS Studio, Original IDE Interface, GAMS Miro, New User Interface, offered to the optimization market since 2019, GAMSP, a tool aimed at Python modelers, and GAMS Engine. GAMS Engine is an API designed to run in cloud environments. It's an enterprise-grade system that runs on a server and offers features like high scalability, load balancing through a job queue, continuous updates, and much more. The GAMS engine automatically schedules jobs and assigns them to a GAMS worker available to solve them. Moreover, it comes with a powerful user management system that allows you to restrict your users' activities according to your organizational hierarchy. The GAMS engine can not only be controlled by a Miro application. Thanks to the use of OpenAPI, Clients are accessible in various programming languages. The image presents the components that have to do directly with optimization, whose capacity must be designed, and that generate costs that the user must assume. The first element to consider is the multi-core and multi-threaded CPU, its architecture, and the software components it stores, which are presented below. Today, operating systems can run multiple programs simultaneously instead of running them sequentially. This is known as multitasking. Multitasking doesn't necessarily need multiple physical processors or multiple cores. A single processor and even a single core can share time between multiple processes. Today, processors work so fast that we have the illusion that all multiple processes run in parallel. If the computer has multiple processors or cores, different processes or tasks can be executed in a truly parallel manner. It should be noted that all processors share RAM. If you have many processors and very little memory, the parallelism effect may be lost due to inter-process interference, which can bog down the machine. Each process can create threads, known as threads, which are independent sequences of code statements. Multiple threads within the same process can communicate and share resources. Multithreading is used to improve the performance of an application by splitting sequential instructions into multiple parts. For example, a server-based application uses multiple threads to handle multiple requests simultaneously. The evolution of multithreading is in constant motion and has been the center of superservers. Depending on the CPU type, a fast cache is used to access commonly used data. Access to the CPU cache is faster than that of the main memory, RAM. Typically, the data cache is organized as a hierarchy of multiple cache levels L1, L2, and so on. The L1 cache is the fastest cache and usually comes inside the processor chip itself. It uses high-speed SRAM, static RAM, instead of the slower and cheaper DRAM, dynamic RAM, used for main memory. The L2 cache is located between L1 and RAM and is larger than L1. There may be a third-level L3 cache, depending on the type of CPU. Each core can have its own local L1 cache. There are multiple architectures for multi-core and multi-threaded computers, which becomes one more variable to be resolved. Clock speed measures the number of cycles a CPU runs per second, measured in gigahertz. During each cycle, billions of transistors inside the processor open and close. The higher the clock speed per core, the better. In recent years, a new supercomputer architecture has emerged, based on the power of parallelism provided by GPUs, graphics processing units manufactured by NVIDIA. This architecture is today the basis of the supercomputers that power GPT artificial intelligence. OPTEX GPU Solver, the solver for artificial brains. Investigates the implementation of artificial brains based on smart devices specialized in solving optimization problems. This possibility can be focused on the implementation of the simplex method, which is the central algorithm around which all the different formats are solved. Another point of interest is that all the problems to be solved are related through large-scale partitioning and decomposition algorithms, which convert originally scattered matrices into dense matrices. Decomposing the simplex method into GPU blocks makes it possible to combine algorithms oriented to dense arrays with algorithms for sparse arrays, which speeds up the process. The research realized by Lamani et al. Consists of the implementation of the simplex algorithm in a multi-GPU architecture, using CUDA, NVIDIA Compute Unified Device Architecture for GPUs. Computational tests have been carried out on randomly generated instances for non-sparse LP problems. Tests show a maximum acceleration of 24.5 times with 2 Tesla C2050 cards. Dense linear programming problems occur in many important domains. Large-scale algorithms, such as Bender's and Danzig-Wolf, result in dense LP problems. This aspect is fundamental when the memory of the process is included in artificial brains. In addition to the effect of the hardware of computers oriented to parallel processing, nowadays practically all of them, you have to know the software to see how it will work in the selected option. In high algorithms there are different implementation options that make different use of parallelism. Each release involves variations in algorithms and therefore variations in cost. The graph presents the effect of the parallel implementation of the standard high-power/mod plan algorithm. The effects are: no parallelism, reduced use of system resources, and longer time to solution. With parallelism, increased use of system resources, and shorter time to solution. Parallelism options. The parallelism options that can be used to solve the same problem using OPTEX are: standard, the problem is solved based on a monolithic model without parallelism. This is the most economical option. Stochastic parallel. There are two options: PSS, multiple monolithic models of the same family are solved using multiple cores simultaneously. A single GAMS concurrency is used. PEM, multiple monolithic models of the same family are solved using multiple cores simultaneously. Multiple GAMS concurrency is used. Large-scale optimization. The model uses partitioning and decomposition techniques to solve the problem. There are two options: LSOs, these are solved using a single GAMS concurrency that operates the loops internally. LSOM, they are solved using multiple GAMS concurrency, in parallel. This option is the most powerful and therefore the most expensive. Each bar indicates the acceleration ratio calculated as the sequential time divided by the parallel time. It is clear that the parallel solution is faster. Any parallel algorithm can run in two versions. Asynchronous, each version of the algorithm runs at the highest speed, and usually, when vacated, it restarts the cycle, and synchronous, there is a point of synchronisms, in which all algorithms must wait for the last one to finish the cycle. It is used for the control and analysis of algorithms. The image compares monolithic optimization solutions versus large-scale optimization solutions. To do this, the asynchronous version of Benders is run for all instances, running until the same optimality gap is reached as with C-Plex after 10 hours. All algorithms run on 15 processors. The C-Plex time divided by the Benders time indicates how many times a monolithic solution, represented by C-Plex, is slower, compared to a solution that uses large-scale optimization, arriving 519 times slower in the most complex instances. The image shows the performance comparison of the additional processors, in which it is shown that the analyzed algorithm, as the processors increase, the marginal performance gain decreases. However, this is not a universal law, since there are algorithms with a higher level of atomization and analysis, in which the behavior of the gain is contrary to what is exposed, such as the case of the multi-level generalized stochastic dual dynamic programming algorithm, MGSDDP, developed by High, which allows solving decomposed problems at any number of levels. MGSDDP achieves a gain in speed, as the scenarios increase, which means a learning process controlled by the algorithm. It is the possible implementation of the multi-Benders decomposition algorithm, developed by High aimed at artificial brains. MBD can be implemented with a unified coordinator, using asynchronous parallel optimization. In the simplest case, one processor should be assigned to the unified coordinator and multiple processors to the subproblems, ideally one per subproblem. In the case of the example, it would be 10 processors in total. 1 for the coordinator and 9 for the subproblems. High's approach to developing large-scale superalgorithms using linear programming models as the core, in this case using C-Plex. Similarly, problems that need to be solved with different methodologies on a large scale can be shared. From a central set of equations, each problem can be adjusted according to the algorithm to be used. Case, cost analysis. Below is the cost analysis for a restaurant oven optimization model, called High Oven. The MOS cost framework is. It is supported by a Memorandum of Understanding, MOU, which includes an expected use plan, not a binding one. Discounts for firm commitments included in the MO. The company pay for time of use, according to the resources that are being consumed. Differentiated prices according to CPU speed, and all its features. GAMS license hosting of the high algorithms, according to the level of parallelism. The image presents the prices of CPU hosting in GAMS is set based on the available models. They stand out for being one of the machines with the cheapest CPU and the most expensive CPU. The cost of a cluster will be the sum of the CPUs that compose it. The image presents the costs of hosting GAMS licenses, according to the products it offers. The rental of High licenses will be done through a monthly rental agreement of the High Oven software. The table presents the characteristics of the cost of the MOS service. Take or pay contract, for the value of the contract accumulated by the purchased rank. Last column. This implies that the value of the installment to be paid is independent of the consumption within the range. Minimum contract for 3 months. Contract terminable at any time. Giving 1 month's notice. High Oven STD model, standard. The problem is solved based on a monolithic model without parallelism. This is the most economical option. There is no limit to the number of spins of the High Oven model. In the month, the cost of running the hosting is paid together with the GAMS licenses, in the GAMS cloud service. The contracts include a minimum consumption clause, which entails a mandatory commitment of resources, and in exchange for this the customer receives a discount. It is a take-or-pay type contract. If there is no commitment, there is no discount. All the elements analyzed must be considered when deciding the most appropriate architecture for the MOS service. High and its team of partners will work as a team with the interested customer to help them determine the solution that is considered most suitable. Mathematical models as a cloud service. Application in energy industries. An oil enterprise-wide optimization integrates mathematical models for each of the links in the oil supply chain, in such a way that supply chain planning is managed with a holistic vision. The design presented was the result of work done for a multi-business oil company. The union of models, and their coordination, forms the artificial hypothalamus of said oil company. The diagram presents an artificial hypothalamus of an IBP process. Integrated business planning. To make decisions, the human brain faces reality, using multiple models that permanently act in parallel. The mathematical models that make up artificial brains act in the same way, autonomously, in parallel, and distributed. Under Industry 4.0, the artificial brain is the evolution of decision support systems, DSS. It is conceptualized as the set of mathematical models, which exchange information autonomously between them, working online through distributed optimization. In a traditional DSS, models are used in coordination, through a manually controlled process. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This union of models can occur from multiple points of view, each of them associated with a hierarchy of dimensions to visualize the organization. Keeping in mind the vision of large-scale optimization, which can have multiple points of view, High developed the multi-Bender's decomposition algorithm, to emulate the coordination of multiple points of view, just as the human brain does. These ideas have their origins in the book 1,000 of Brains by Jeff Hawkins. A case of coordinated parallelism in a brain is that of octopuses that have 9 brains, 3 hearts, and 2 memory systems. These brains are used to control independently each of its 8 limbs, allowing the octopus to move with agility, and react quickly to any threat. In addition, it has a central brain. This is one case, among many, of an animal with multiple brains and multiple hearts. Since we are talking about artificial brains, built by humans, we can extend the concept to an artificial brain with multiple artificial brains. The question is, which is the better artificial brain, one based on the human brain, monobrain, or one based on the octopus, multibrain? In building artificial brains, High is researching the coherent way to implement artificial brains with multi-brain capability, in which second or third level brains control part of the organization with sufficient autonomy, and faster reaction ability. Each arm can represent a region, a site, a business, and/or an administrative function. Software production is at the heart of a highly complex mathematical modeling activity. To facilitate this process, Hy and GAMS offer several alternatives, one of them being the Hy GAMS Mathematical Model Software Factory, which can produce artificial brains ready to work in MOS mode. As George Bernard Shaw would say, "Some see the things that exist and wonder, why? But Hy dreams things that never existed and wonders, why not?" This free thinking has made Hy a leading company in artificial intelligence for decision making. This thinking is enhanced by the alliance with GAMS. Thank you for your attention.